Hello, my friends. I greet you all. Let's as we study this QR decomposition method, where we use it to factorize a matrix. You see, a matrix A is equal to QR matrices, where Q is orthogonal basis matrix and R is upper triangular matrix. Remember, upper triangular matrix is a matrix where below reading diagonal is a 0. Okay? For example, we are given a matrix A, okay, with a dimension of 3 times 3. Decompose it into QR. So here we have our formula for Q. This is a column 1, column 2, column 3, where we take V1 over magnitude of V1, V2 magnitude V2, V3 over magnitude V3. So we rate our matrix with the composite into some columns, A1 to be this column, A2, column 2, A3, the third column. Okay? So then we use this method decompose or to find Q. Okay? Let's start step by step. Then, after rating these A's as a column vector, we can calculate V1. Okay? V1 is equal to A1 as column 1. You see? Okay? This is also A. They are the same. So then, we compute V2. V2 is A2 minus dot product for V1 and A2 over dot product of V1 and also V1, then after dot V1. So here we can compute it. This is vector of A2 minus this is V1 dot A2, then after this is A1 square, also dot V1. So 1 dot 0 is a 0, 1 times 2, 2, 2 times 2, you get 4, then after this one, you get 1. It is 6 over 6, you get 1. So then times our vector v1. So then after you take 0 minus 1 to get minus 1, 2 minus 1 to get 1, 2 minus 2 to get 0. Okay? Then after we can compute our V3. V3 is A3 minus dot product of V1 and A3 over dot product of V1 also dot V1. Then after you take this one minus this. So it means here you can put here bracket. Okay, bracket. So why? So we computed this after we subtract this one. Okay, let's do it step by step. Then you take A3 minus our V1 dot A3 over V1 dot V1, then times our V1. So then here subtract v2 dot a3 over v2 dot v2, then times v2. You compute here, this one, remember, is this one times this one, plus this one times this one, plus 2 times 3 to get here 6 over 6. Here also, minus, you compute here to get 1 over 1, which is equal to 1, we mean it by our vector. So that's one here. You take this vector, vector 1, okay, minus another computed vector. At the end, we get as v3, which is equal to -1, -1, and 1. Okay? So we have already seen our v. We have v1, v2, and v3. So we can proceed. So then we have already calculated the v1. So v2 is equal this vector, v3 is here. So we can compute our q, which is equal to v1 over magnitude v1, v2 as a column vector over v2 magnitude, v3 over 3 magnitude. So we can compute magnitude for v1 is this one square plus 1 square plus 4 square, which is equal to 2 square, we get 4. So then after you get root 6. It means 2 square, 1 square, 1 square, we will get root 6. Magnitude v2 is equal to root 2. Magnitude for v3 is equal to root 3. So then we can compute our q. Q is equal to, as we said, is a column, is 1 over root 6 from here. You get also 1 over root 6, okay? For here, you get this -1 over root 2, 1 over root 2, then 0 over root 2 is a 0. We compute for this column, which is equal to -1 over root 3, -1 over root 3, so 1 over root 3. So then we can find the R as the matrix for upper triangle. Okay? So let's also compute our R step by step. So our R, recall Q times R is equal to A, as we said before. So it means our R is equal to Q transposed times A. So we take our Q transposed, we take this one, remember row become column, so you transpose it, then you multiply by a matrix A. We will get this one times this one, plus this times this one, plus this times this one, to get one entry, as we see here. Also for this one, we get this row times this column, okay? This one times this one, get 0. This one times this one, 2 root 6, plus this one times this 2, so to get this. How we get this one? We multiply this row by this column, okay? Also, this row is gained by taking our row times column 1. This one gained by taking this times this one. This one is getting from this row multiplied by this column. So we get this one entry by addition. For this, we compute by taking this row multiplied for this. For here, you take this row multiplied by this column. At the end also, you take this one multiplied by this column. So at the end, you add, you will get upper triangular matrix, you see, by putting, okay, you get upper triangular matrix by addition. Let's just see. By addition, this one, you will get 6 root 6. Here, you will get 6 over root 6. And also here, you get this one. So you will see that we have upper triangular matrix because below of reading diagonal or main diagonal, you have 0. This is the upper triangular matrix. Okay? So therefore, A is equal to Q times R. This is our R. We have seen our Q, remember before, so times our R. So if you prove this, you can multiply this. At the end, we will have our A. So we can conclude that our matrix A have already decomposed into QR. QR, you see? This is how you factorize a matrix into QR system. If you multiply this matrix Q by this R, you will at the end get your matrix A. So therefore, matrix A has already decomposed into QR. Thank you for watching. Remember to subscribe to my channel and also share our video to many mathematicians who are learning linear algebra. Thank you very much. Goodbye.